What's up, Miss Fatty? I couldn't get the app to work on my computer. I don't really know. I'm not a techie boy, but I also never pass up the opportunity to show off a good fit. Um, so my question was, sorry. Um, uh, so my question was, what physics are taken into account when someone builds a gun, tank, or other war equipment? I chose this because I've always been interested in war, and I'd like to know what physics are involved in it. I mean, I've never owned a gun. Well, obviously, I can't because I'm 17, and my family never has. But I've always been fascinated with like all the movies and stuff. Um, and I think the class that relates to this most is physics, obviously, because I figured that to get a bullet moving through the air, you gotta have a lot of physics involved. So what do I already know about this topic? I took America at War this year, and so I got a little knowledge on how different guns are made and the different parts of a tank and whatnot. But we never really went into depth of the physics of war. So next up is for the research. I found out that firearms are built with friction, heat, gases, and projectile motion in mind. The energy conservation, or I'm sorry, yeah, wait. The energy conservation efficiency of a firearm strongly depends on its construction, especially on its caliber and barrel length. So that means like, though I think the longer the barrel, the more like accurate the shot will be. And yeah. So then I said, then the next one was assuming the gun and shooter are at rest. The force on the bullet is equal to that on the gun shooter. This is due to Newton's third law of motion, which we learned. For every action, there's an equal and opposite reaction, of course. More research. I got since force equals the rate of change in momentum and the initial momenta are zero, the force on the bullet must therefore be the same as the force on the gun and shooter. All right. So, and then for the velocity of a gun slash shooter, is V equals mv slash m. And this shows that despite the high velocity of the bullet, the small bullet mass to shooter mass ratio results in a low recoil velocity, although the force and momentum are equal. And then lastly, the smaller the bullet, compared to that of the gun shooter system, allows significantly more energy or kinetic energy to be imparted with the bullet than the shooter. I found out there was a lot more physics involved in a gun than I thought there were, so that was exciting. Let's see here. Sorry. Connections. How can you connect what you learned to your classes at school? Obviously, I can connect this to physics because I feel like that guns are basically all physics. And how does it connect to your prior knowledge? Like I said before, all the action movies, they have all the guns and explosions, everything like that, and I've always been fascinated with it. And I just never realized that I've been looking at physics the whole time. So thanks for ruining that for me too, school. I'm kidding. I'm playing. I'm taking away. I learned that physics are used to make guns better, as they are still being developed today to perform better. And what skills did I use during this investigation? Obviously, research. I had to go online, but it was worth it. You know, I was fascinated by this, and all my questions were answered. And that's it. Thank you.